If we talk about, Rima Sinam from Bahrain, good afternoon. So if you talk about advanced image classifiers, we see different terminology today, and the terminologies are basically learning terminologies like machine learning, and then further we see deep learning, and I've added something human learning, right? So here you can see there are common words of learning, and learning means acquisition of knowledge or skills through study, through experience. If we do something and then we learn, or being taught by somebody. Like today I'm teaching again the advanced topic. So here with this learning, today in the market and different institutes, people are talking about machine learning, and then further subset of machine learning is deep learning. And if you see between these two, I have added one more thing: human learning. So human learning is very important, which is top of all the learnings we have to do. So coming to machine learning, it is basically application of artificial intelligence. It is one of the application of artificial intelligence, AI, that provides systems ability to automatically learn. So here nowadays the trend is the algorithms are data driven. That means they are learning with respect to the data. It is not that always decisions given by the user or by the human being. They are getting trained, they are getting learning from the data itself with time. And like human beings, it improves from experience without being explicitly programmed. So it is not basically programmed to do that activity. With experience, this is very, very important term. The human being or any creature have some experience. They carry that learning as an experience, and using this experience information, they take very critical decisions. So the algorithms presently also trained like that. They are getting learning. Like if you go on typing in the word file, and there if you check for grammar and you say this word is okay, this word is okay, so like that information is going in the database, and that way the simplest your word process is learning. If you are using Google Earth, so every time you search some words, so Google Earth is learning with respect to that. This person always looks these words, so that way he's learning to help you out about that. If I'm looking for shirts, so he will goes on giving me some ideas, some new shirts coming up in the market. So that way, the way we treat the system, the system is getting trained by the user itself. So that way the learning comes, and here we can see broadly 4 type of learning. Supervised learning, which I talked yesterday. If we have training data, ground truth data, so we can train the algorithm with respect to training data. So that is supervised learning. If we don't have any training data, then it is unsupervised learning. Then nowadays with the machine learning and deep learning, there are 2 more type of learning words are there: semi-supervised and reinforced learning. Semi-supervised means when we have a very little labeled training data, and when we have large unlabeled training data. So in this situation, we have to use semi-supervised learning. So it is not full supervised learning, it is partial semi-supervised learning. And 4th one is the reinforced learning. In the reinforced learning, the algorithm, we have to give the rewards. It is positive or negative rewards. So we can say rewards or punishment. Like in the real life, if we do something good, we get the reward. If something bad we do, we get the punishment. So that type of things happens, and then we learn that these things we should not do in our life, and these things we should do, and that we are learning through reward or punishment. Machine learning, if you see their broad applications, stopping a minute. So I'm coming back. So machine learning, if we see today, we can have broadly its application as classification use to divide the pixels into different groups. Like here, if we have 3 by 3 9 pixels, so we are dividing as a settlement pixels and water pixels, and some pixels are unclassified. Second application we are using nowadays very rigorously for prediction purpose, like for rain prediction, it will occur or not, and that is your approach called regression approach. So these are the two broad applications. In classification, as I mentioned, this can be supervised or unsupervised. Machine learning algorithms. So nowadays, if you attend any ongoing courses which are there in the market, they generally consider the machine learning algorithm as support vector machine or random forest or decision tree. So these are the three broad algorithms they think to be kept under machine learning, but that is not true, because maybe that course is designed specifically. If you see, maximum MBA people have designed and the algorithms, but today if you see any classification or regression algorithm is coming under machine learning algorithm. So here if you see, yesterday I talked about C-means algorithm, maximum likelihood classifier, linear mixture model, dense vector machine, random forest, a decision tree, fuzzy classifiers, ANN, and further more classifiers. So any classifier which is there in the literature comes under machine learning algorithm. Maybe some of the algorithms has not been used in the literature for different applications, but it is there as a pure science. So that is coming under the machine learning algorithm. So any algorithm which can be used for classification or regression purpose comes under machine learning algorithm. There are few issues you can see in while processing the remote sensing data. Again, can you just tell me my voice and PPT is fine? And I hope all have joined. You can drop the message in the chat box so I can read immediately. The things are going fine. Okay, Dawa Ram missed. Yeah, it's good. Lot of people are. And if you have any doubt, you can type here itself. No issues. I can take the doubt and immediately I will reply. It's all your choice. So I'm continuing further. If things are going fine. So there are some of the issues like different aspects while handling remote sensing images. One of the main concern is mixed pixels, right? So here you can see there is a 3 by 3 image, and which is representing, some pixels are representing grassland, which is a pure pixel. Pure means there is only one class. Here 2 pixels are representing water, so it is a pure pixel again. But these 4 pixels are not pure. It is partially water and partially grassland. The question comes, what the label you will give to this pixel, because it is say 70% water and 30% grassland. You may say water, so you are underestimating or you are over classifying the water information and underestimated the grass. And you can see the real life problem when you book a ticket, and when the ticket is confirmed, so 100% you belongs to going class and 0% you belongs to not going class. But there can be one situation when the ticket is on waiting. So what you feel? So if your ticket is on waiting, what is your reply about going and not going? You can type in the chat box so I can feel that after post lunch you're not sleeping and you are continuing to learn as a human learning. So when your ticket is on waiting, it can be air ticket or railway ticket or bus ticket, whatever it is, if it is on waiting. So what is your reply when somebody asks that you're going or not going? It's very simple, real life problem, and I think you're giving the answers. Let me see what is the answer you reply. From Bahrain, from Mauritius, from Bhutan, I've not seen Kenya. There were people there yesterday, from Kenya and Zambia. Yeah, pending. Miss Malika Ruzi says pending. Pending means what? Ticket is on pending, of course. But the question is, what is your reply? Both in doubt, may go or may not go. Dawa Ram from Bhutan says may go or may not go. Mathematically, if you have to reply using mathematical terms, mathematical numbers, so what do you reply? Right? One thing is it is confusing stage. So you reply basically say 70% I may go and 30% I may not go. So that percentage is degree of belongingness. Yeah, you can say 50, 1 by 2. Yeah, 1 by 2 we generally go for soup, right? Make it 1 by 2. From one soup, make it 2 soups, 2 ball soups. So here we can say 70% or 0.7 I will go and 0.3 I will not go. So 0.7 is degree of belongingness of going, and 0.3 is a degree of belongingness of not going to for the journey. So here, so these pixels can be handled through fuzzy concept. So how do we get this 70%, 30%? We are applying some fuzzy logic in that. So here with the fuzzy approach, we can handle nicely the mixed pixels. Second is noisy pixels. So here you can see red dots. How to handle these red dots, which are noisy pixels, unwanted pixels, or unwanted class. Both are noisy pixels. So we can handle through Markov random field or local convolution method. So these are the two methods through which we can handle these noisy pixels, because they incorporate the neighbor pixel, neighbor correlation information is added, and that way we can handle this information, these noisy pixels. So, or we can say isolated pixels. So if you are mapping at 1:20,000, so there is one pixel which is showing as a water, even though it is a real water, but there is no meaning to consider this one pixel at 1:20,000. So it is isolated pixels. So how we can eliminate these isolated pixels? Through Markov random field or through convolution, local convolution method. So they are filtering approach or kernel approach using the neighbor pixels. We can add the effect. You can see the real life example again. In India, there is one province called Punjab. So in Punjab, what happens? Alternate house, if you check, everybody from that each house, people have gone to Canada. So if my house is there, I can see my neighbors. In my neighbors, one person has gone to Canada at least. So that, since from neighbors, every one person has gone to Canada, that will make me, or from my family, that at least one person should go to Canada. So it is a neighbor effect on my family, which is making that at least one person or two person may like to go to Canada. So that's a neighbor effect. So same way here, we can add the neighbor effect through MRF or local convolution method. Here, local convolution method is more simple to apply than MRF. We have experimented both, and I will show you in the coming slide. Then some more issues, non-linearity between classes. So here you can see, you can separate the two class, this rectangle and triangle, very easily with this hyperplane or hyperline. But here if you see, the separation is a circle. So it is non-linear separation that cannot be handled by any classifier. Whatever classifiers I just talked, which come under machine learning domain, cannot handle the non-linearity. So what we have to do, we have to apply some mathematical function called kernel. K-E-R, kernel we have to apply, K-E-R, sorry. And by this, what happens, the kernel makes non-linearity to linearity. So it is increasing the data dimensionality. It is two-dimensional here. It can make the data to be three-dimensional with this mathematical operation. And once the data is converted to three-dimensional, and that is mandatory if you see that the data has become linear. So we can use this kernel concept to take the data to higher dimension and see that the classes are linear. Once the classes are linear, then you can apply any best classifier to separate these classes. So for mixed pixels, the solution is we can apply fuzzy set theory. For noisy pixels, we can apply contextual information approach through MRF or through local convolution method. So here you can see one list 4 image long back we have done, and this is a water body. There one dam towards east of Uttarakhand province, and this is a road and having eucalyptus plantation, and there is shadow along the road, and here also you can see a lot of shadow due to the plantation. So what is happening when we are classifying? So this is a field photograph long back we have taken, and when we are classifying without contextual information, you can see shadow along the road is coming as a noisy pixels, and here also. So just with fuzzy classifier we are applying without contextual information, but here with contextual information you can see the shadow has been minimized and is totally removed here. So that is a contextual effect, neighbor pixel effect rather. And then you can see we have experimented with 2 methods. So this is the input image of the same area. So the MRF we have applied through smoothing effect. So you can see how these small water bodies, some of the details has been lost here. But here if you see through DA, discontinuity adaptive prior of MRF, the details are preserved, and it is basically preserving the boundary of the class also. And then we have experimented with the noise effect, intentionally adding the noise. So this is the input image. We have just classified with the local information method here MPCMS, and that this image is without noise. This is the output basically, and there is no noise added in this input. So here in this input we have added 1% noise intentionally, and try to see how the algorithm is capable to handle this noise. So here you can see in the output, it is more or less equivalent to this output. There is not hardly any difference. So this was 1% salt and paper noise has been added, and later on we have increased this noise to be 5%. Right, so at 5% you can see again the output is quite much better, and the algorithm is able to handle the noise. So here non-linearity we can handle through kernel approach. Spectral overlap, so this is one solution. If there is a non-linearity between classes, like one class is coming like this and second class is coming like this, so what may happen here, the separation between classes like this, so it is a curved line. So how to handle? So we can use the kernels which takes the data to higher dimensional and make the separation linear. So that's a linear separation between 2 classes, then we can apply any classifier. So here we are adding the kernel. So we have worked with this also approach. Second, yesterday somebody talked about I think temporal data or some spectral overlap between 2 or more than 2 classes, specifically in the vegetation. So if there is spectral overlap between 2 classes, the solution comes to use temporal images. This is very strong information in the remote sensing domain. If we use temporal images, we can identify, we can handle the spectral overlap, and we can map the specific class also. Then here you can see spectral overlap between 2 or more than 2 classes. So here they are linearly separable, but here you can see more or less non-linear, and they are totally going inside that crop, inside that class. So there is non-linear separation, and here it is hardly you can make any non-linear separation, or more or less it is showing a spectral overlap. So how to deal with these cases? We require temporal information. So here you can see in the temporal what we can do specifically an example of a crop. Crop is sown at this time. So here small germination, then it is growing further. So vigor is coming, the chlorophyll content is increasing in the field, and it is maximum grown, and then flowering is coming up, and then it is going towards harvesting stage. So if you extract the NDVI or SAVI is much better than NDVI, you can get the NDVI or phenological growth with respect to chlorophyll content, which is increasing, and then it is slowly dropping after the harvesting stage. So this information we can incorporate through temporal images. So within agriculture fields, mapping specific crop at level 2 or level 3. Level 1 means just I am mapping a field, agriculture field with crop. I do not know what is the crop. But if I go second level, I can map a field where I can say this is wheat crop. Third level, I can say within wheat, it is young wheat or late sowing wheat or specific variety of wheat. So this is third level. First level, second level, third level. So how it is possible to go further level of classification? Through temporal images. So spectral overlap between different existing crops can be dealt through temporal information. And when we are using temporal data, what it does, it incorporates phenological information. Phenological means different stages of vegetation are incorporated through temporal images, which is very important when we want to avoid the spectral overlap and when we want to map a specific crop. So here you can see one example of temporal data. So what we have tried to do with one of the MTech student 1 year back, it was done. We have tried to map paddy field transplanted. Paddy means rice fields transplanted at specific date. So date of transplantation was 8th of July. So we have taken 2 dates before transplantation, that is 19th of June and 29th of June, and 1 date after the transplantation. And here you can see this is an example of multi-sensor. This is your sentinel image 2, this is sentinel image 2, this is Landsat 8 image, and this is sentinel image 1, SAR image. So here we are using sensor from 3 different sensors, from sentinel 1, sentinel 2 and Landsat. So here we have tried to map the transplanted paddy fields. So these are the transplanted paddy fields. But one problem we found, there is a dry canal in the area which is showing as transplanted paddy field. So there is a false classification, again spectral overlap of the dry canal with the transplanted paddy field. So what is happening on the field in the 4 dates, initially paddy field was empty and then it was filled with water, and then transplantation has been done and further growing of the paddy, that seeds were going on. And if you see the stage of this canal, it was dry here, then again it was wet due to rain, and some grass has grown and further grass has grown. So this change, it was dry here, then here it is water, transplanted, and it is growing. So same thing you are happening, it is dry here, it was watery here, and then there is a grass here. That means we can say it is directly representing as a transplanted, and then further growth. So here in the time domain, the transplanted paddy field and the dry canal was giving same signature, and we are not able to map still, even though after using 4 date image with the multi-sensor approach data. So what we have done, we have added one more image of 6th of March. So this has given here one more image for the transplant paddy field. The 6th March, there was wheat, the previous crop wheat, and the canal was dry. So canal vector has become different, and in the time domain and the transplanted paddy field vector has become different. And here you can see that canal has been easily removed on the output. So sometimes we have to see optimum temporal dates. It is 2, 3, 4, or 5, or maybe more, depending upon situation. In this case, we have to require around 5 date images to really remove that canal canal area. So here we have done this through deep learning algorithm. I will give you some of the maybe later. So here you can see CNN, convolutional neural network, we have tried, and you can see the relationship between epoch, number of iterations with the accuracy, how the model has gone, and here again epoch with model loss. So the structure of the model, if you see, 128 layers at this convolution layer, 64 this one, and then one for max pooling, one dropout, and fully connected layer. And we have experimented CNN with LSTM, that means RNN layer has been added here to make it as a hybrid model. Here convolution 132, then LSTM 64, then dropout 0.6, and like that we have taken the structure, and it has also given good result, but not much better than CNN. This was not much better than CNN. In the previous, CNN was much better than the hybrid approach. So these are the model parameters, and you can see we have taken 1D sequential model, and we have just taken 20 samples, 30 samples, 40 samples, and 50 samples. We found 50 samples are more than enough to train the 1D sequential model. We don't require huge training data as there is myth in deep learning that we require large training data, but not always, right? So don't be afraid that always we require large training data. Here what we found for these type of problems, we don't require large training data. Here you can see some of the example of sunflower crop in Haryana province near Kurukshetra district. There is one Shahbag area where a lot of sunflower crop is grown. So here we have taken time domain data. Sunflower crop is sowing by March. So we have data from 21st March and we have gone up to 30th of April. Crop is getting harvested by May and June. So using these temporal data sets, we are able to map early sown sunflower, middle sown sunflower, and late sown sunflower. Some of the important things of the temporal images we have tried for urban area also, where we generally go for built-up change detection, but here we have gone very specific change detection. So what we have tried, we have not just gone for built-up change detection, but we have gone at building footprint change detection using 10-meter spatial resolution. The question was, can we map the building footprint changes which has occurred by 10-meter spatial resolution? Answer was yes. Used with 2 dates images here. The first date was October 2013 from Landsat 8, and which was pan sharpened, and then it was made to be 10-meter after resampling so that it is compatible with Sentinel-2 image. Here we have taken the Sentinel-2 image October 2019, and we have just applied fuzzy based MPCM classifier. Why MPCM? Because this is fully capable to handle the mixed pixels. It is fully capable to handle to make the cluster compact, and very important, it can handle the noisy pixels very nicely, and we can get the much better results. So here you can see we have experimented within Dehradun, and we have taken one training site at Baruwala. So here you can see we are able to, and then some test sites at Doon University, Kalidas Road, near surrounding of our campus here, then Sabji Mandi, the vegetable market of Dehradun, and then bus station that is called ISBT Dehradun. So here you can see for Kalidas Road, we are able to map different type of buildings like Shivalik Apartments here. Then Vikram Sarabhai Hostel, which is a new building in our campus. Vikram Sarabhai Hostel, this is a hostel building. Then Golden Jubilee building. So here, this is your Vikram Sarabhai Hostel, and this is your Vikram Sarabhai Hostel, and this is Golden Jubilee Hostel. And there is a stand-on building outside our campus having thin shade, which was also able to map. And then one more apartment called Meridian Height here. So these buildings we see daily and which were able to map, but we have done with conventional change detection approach. We are not able to map these buildings so nicely. And if we have experimented with NDVI approach, still we don't get that information. And you can see this building was present in 19, and this building is not there in 13. All right, you can see this Vikram Sarabhai Hostel. There's a park here, but now you can see the U-shaped building where I always played badminton in the evening hours. So this building was quite possible to map with 10-meter. We have done for Baruwala. You can see the rectangular buildings which were mapped, which was not present previously. If you see here in the Google map, it was not present. There was only vegetation, but here you can see the buildings has came up. So we are able to map with this temporal information. But with NDVI approach and through conventional change detection approach, we are not able to map up to building level, but it was giving the built-up change, but not up to building level. You can go on asking any questions if you have. I don't mind it. I don't mind it. If you have any questions, please drop the questions here. I can take immediately. So I don't mind. And if you don't ask, then I assume you are listening 100%, or you're not listening, or maybe you are sleeping after lunch. It's good, nice to sleep. And during class, you get a good sleep. Okay, nevertheless, coming to Doon University, again, a few new buildings were mapped here. Then at a main vegetable market of Dehradun here, surroundings of that market, we can able to map the new apartments. Lot of apartments has came at the surrounding of the main vegetable market, and we can see these patches which are showing as a new apartment, which was cross-checked in the ground. And at the main bus station of Dehradun, that is called ISBT, we are able to map the new malls, and some new offices came around the ISBT. This was the ISBT campus, but at the surrounding, if you see, within last 6 years, lot of new buildings has came up. Then we have given last year onwards, and 2-3 research paper also getting published. At least 2 is already published, and 2-3 are in pipeline, talking about heterogeneity within class. Here, if you see this forest patch, it is not so uniform. There is some variation within the forest, even though it is a one cluster. And here you can see in the open space, somewhere it is dry, the white patch, and the cyan color is moist. So it is not so homogeneous. This is more heterogeneous. So how to deal the heterogeneity within class? So we have done the concept of using individual sample as mean approach. The conventional algorithms in the machine learning, they use the mean parameter. So from the samples, they calculate the mean. So mean cannot represent all the samples or all that class with 100%. But if we take the samples as it is, so that gives you individual sample as mean approach, and each sample impact comes on the output which is generated through the classifier, and that way it can handle this heterogeneity. Now we can see this concept also in some of the outputs, which is already published under elsewhere and the JAR Journal of Applied Remote Sensing. So here what we have tried to map the mustard field. So here we have tried with individual samples, and here you can see this is the training field which is homogeneously mapped. But when we are using the same algorithm through statistics, that means through mean parameter, and if you try to see the same field, it is not mapped properly. There is some pixels has been left. So this study area we have taken near Banasthali, which is a school cum university only for girls. So this is a campus, and at the surrounding of this campus, it was possible to map this area to study these crops. Yeah. Then we have done it for grasslands in the same area. So in the campus, you can see there's a cricket ground, there's a parade ground, and there's one more field here. So these fields has been mapped very nicely when we are using individual sample approach. But through statistical approach, you can see these field has hardly picked up. And at the surroundings of this area, hardly any grasslands has been mapped. But here you can see plenty of grasslands has been picked up. Again, it is a temporal data, but we are providing each sample as a raw, as a mean sample in the classifier. We are not generating mean, we are treating each sample as mean. And we have tested with wheat crop also. So these are the 2 test fields which has been mapped homogeneously. But here if you see, they have not been mapped when we have taken mean parameter from the samples. But when we are using individual samples, you can see these wheat fields has been mapped very nicely. So this was more about machine learning, and then today people have moved from machine learning to deep learning. Since your topic is advanced, so I have to go to advanced, right? You understand and don't understand don't matter, but enjoy the journey, right? That way something will go inside your brain. So machine learning to deep learning. So deep learning is a subset of machine learning. So it is a modified version of artificial network. So if you talk about deep learning is a subset of machine learning, as I've told. And then deep learning is basically modified version of artificial neural network, ANN. Right? ANN looks to be quite advanced algorithm compared to that conventional algorithm. But today when we talk about deep learning, it is a modified version of ANN. So why it is called deep? That is also one question. Deep means from a given data, the algorithm generates large number of dimensions from the data called feature maps, right? Using different filters or different convolution layers, different convolution operation, it generates large number of layers. For example, if you have 4-band data, so through convolution operation, you can have 10 layers. So from 4, you have 10, and if you can increase that to be 20, 30, 64. Nowadays it goes like 32, 64, 128. So from 4 band, you may have 32 layers, or you may have 64 layers, or you may have 128 layers. So that way, when you take the data to very high dimensional domain, some of the hidden things, hidden means you can't see in the normal data, but in the higher dimensional domain, you can see that hidden information very nicely. And that's why number of times the deep learning algorithms gives the result very nicely, and they handle the heterogeneity by default, because from the training data they don't generate statistical parameter. They are not statistical algorithm, they are learning algorithm. That means they use only the weights. So they take the training data as it is in the model, and that way each sample gives its impact in the model, and that you can see in the output. I can give you a very simple layman example of school. There is a class, that means you have a teacher and students. One teacher says, I have taught this topic, and in my class, the average marks scored by the students 80%. That 80% numerical value may be satisfying to the teacher, but not the students, because for the students, marks are going from 60% to 90%. Or 99%, but teacher says in my class average score is 80%. But that average does not represent the marks of all students, because the marks are going from 60% to 99%. If the teacher says some student got 60%, some got 65, some got 70, so this range of marks is more realistic to the student marks. So that way, when we incorporate the sample information as it is, that can handle the heterogeneity, which is happening by default in learning algorithms, but we have made the same concept to be achieved through fuzzy-based classifiers when each sample is given as it is in the classifier. This you will not see in the book. Last year we thought, and we have already published 1 paper, and 2, 3 are pipelined, which will be coming up in the few months in few journals. So deep learning have applications, can be used for classification. I have already shown you for paddy, transplant paddy fields. That was through deep learning we have done. This has very strong application for detection, to detecting any object like in military and so forth. Image transformation. Image transformation means if you have a rose image, you can convert to lotus image. If you have elephant image, you can convert to lion image. So that is called transformation. So there are some models which can transform the image. And with the deep learning classification algorithms, if you see, that is like CNN, RNN, convolutional neural network, recurrent neural network, and their hybrid versions, like we have used CNN with RNN. So this was a hybrid approach we have tried in while mapping the transplanted paddy or rice fields. So here you can see the few outputs from a given Formoset image of 4 band, the output from fuzzy FCM classifier, PCM classifier, ANN classifier, and then CNN classifier, and then MPCM. If you study all these outputs, you will find the CNN has least heterogeneity effect. So they are more homogeneous. All these classes are quite homogeneously mapped from the given input image. So here the classes are wheat class, this is a dry river, this is a water body, Ganga river, this is your mixed forest, this is eucalyptus plantation, this is a canal coming from Ganga. This is east side of Haridwar city. Haridwar city is just 70 kilometers from east towards from Dehradun. Then we have tried to use deep learning as one of the model called GAN, Generative Adversarial Network, which can transform the image. So here what we have taken in the temporal domain. The problem is when we are using optical image, there are chances to have few clouds in the image or more densely populated clouds. So how to use the images which are having cloud, or these images are waste, or we can do some processing. So we were having one image of 27th October 2029, and the second image was 30th of October 2029. So this image was having cloud. So what we have done using the GAN, this information was used as a true input, and using this information this image has been processed and we got this image. Now this image is more or less cloud free. So we can say this is a modified image of 30th October 2029. And this image, we can use it as in the temporal domain. At least we have made up to certain level this image to be useful like this. So we have used it this for one of the city in Patiala, that is in Punjab, for paddy stubble burning, the dry biomass which is burned by the farmers. So how to map that every 5 days interval. So we have done it. So this is the one structure of GAN. This is for your unit generator, and this is for patch GAN discriminator. And if you see under detection algorithms of deep learning, there are large number of algorithms like RCNN, fast RCNN, faster RCNN, mask RCNN, fused fully CNN, XGBoost, SSD, single shot detector, or YOLO, you only looks once, and so forth. So there are other algorithms. You can see one of the example for very high resolution image where we can see the buildings and other things very nicely. So we have tried here SSD model, and we were looking to map these buildings. Basically, if you classify very high resolution images with a conventional classifier, so what may happen with this building, the surrounding, the road and the ships may get classified with this building. So what we have done initially, we have done the detection of these buildings, and the detection algorithm create a bounding box along the building. So using this bounding box, we have used this bounding box as a mask, so that the area has been masked outside the building. So it is just covering the nearby surrounding of the building. So using this masked building pixels, we have used these pixels for normal fuzzy classifier, which can accept single class. And that way, through masking concept of deep learning, it was possible to map only the high rising buildings, and there is not much spectral overlap with the surrounding. And here we have used just single date image of very high spatial resolution image. Then we have used deep learning for brickling. It is one of the activity for making bricks in India, specifically the top surface. If it is clay surface in the North Gangetic plains, it has this good clay soil, which is used as an input for making the bricks through local furnace. And this is a brickling elliptical shape. So can we identify these activities which is happening in the surrounding, so that we can map, we can identify, we can locate them with respect to coordinates, we can count them. After counting, we can estimate how much is the emission coming in the air through these bricklings in an area. And this area has been excavated where they are using this soil up to 2 meters to make the bricks, and that kacha brick is fed in the furnace to make burnt brick to be used for construction purpose in the buildings. So here you can see through detection algorithm, we can detect the bricklinks, and we can create a point map of these bricklinks, and we can do through mask RCNN also the identifying these bricklinks, and we can get the coordinates of these bricklinks as lat long, so that if you want to locate any of the bricklink on the ground using this lat long information, we can identify these bricklinks on the ground. Then for some cases, we have tried to map the hangars, which is some of the aircrafts are parked. So near to the airport, you can see some small huts where the aircrafts are parked, called hangars. Yes, we can map these. We can create a point map, and we can get the coordinates of these hangars. We have also experimented to map this cauliflower. This is UAV images. UAV images for vegetables. So we want to map this cauliflower. Here you can see the cauliflower is a very heterogeneous object. Somewhere it is dark leaf, somewhere it is light leaf, somewhere there is shadow. So this cauliflower itself is a heterogeneous object. So how to handle? So we have experimented the same individual sample as mean approach in heterogeneity, and we got some success, and further we are doing refinement in this output. Here you can see the individual cauliflower. And before I stop, I can show one more slide. just about a specific crop. Somebody was asking. Here, what just today itself, one student has presented on isabgol, which is a medicinal plant, right? So this is a isabgol crop, which is basically totally medicinal plant in Rajasthan area, specifically one of the district called Jalore district, and using the individual sample as mean approach. So here what is happening, if you see one agriculture field, there can be some pockets in that field where the crop is not so much healthy, and that may be giving some different impression on that image within the same field. So within the same field, you can see there is some variation of the crop due to proper water is not applied, or fertilizer is not applied. There can be shadow from a tree. So there can be any number of factors which is not uniform in the same agriculture crop field, and that's why that field does not appear as a homogeneous field. So here's tried for Jalore Rajasthan district in Parwa village, and you can see this isabgol initially growing field in two different fields. This looks like this, and there were other fields like mustard crop, cumin, spices, and the wheat field, fenugreek, again spicy, and then castor oil field. So he has tried to map the castor oil field here. Sorry, isabgol, not the castor one. So here you can see that the temporal images were taken from 31st December to 31st March to incorporate the phenology of the isabgol crop, and the central data you can see 10 band and 20 band. 20 bands were made to 10 bands resampled so that they can be used in the data set. So here what the student has experimented using different indices with different band combinations. This is the proposed CBSI NDVI approach by us. That's called class-based sensor independent. Class-based sensor independent. That means by this approach, it will not ask the data is from which sensor. It will pick up the bands by its own, and that well-suited bands will be considered in the NDVI to generate the indices. So that this approach does not ask where is your NIR band and where is your red band. It finds out the best suitable bands so that that class of interest has been enhanced, because the name says class-based sensor independent. So sensor independent means it does not ask any sensor name. Class-based means we have to just give that this is my class through a click. This is my class of wheat or water. So automatically it will generate the indices for all the temporal and data sets. So here then later on we have experimented with red with NIR, this conventional NDVI, then using red edge 1 with NIR, red edge 2 with NIR, and red edge 3 with NIR. Then optimizing the temporal dates through separability analysis. Separability I covered yesterday. There we are optimizing the number of bands. Here we are optimizing the number of dates of the data using temporal indices database as a training data. So here she has experimented with the mean parameter from the training data or individual sample as mean approach, and she found this is much better giving solution. And the assessment was done through mean membership difference, and she can find out the study individual sample as mean is much better, and then best band in NDVI. So these are two outputs she has achieved. And this is the spectral profile of different crops with respect to NDVI in time domain. And you can see isabgol crop is this one. So it is quite unique profile in the time domain. If you take single date, maybe 2-3 crops may give same signature, so you cannot distinguish them. And here she has tried the indices with the different band combinations in NDVI. It can be CBSI NDVI or normal NDVI, or NDVI with red edge 1, NDVI with red edge 2, or NDVI with red edge 3. So here you can see the CBSI NDVI is still quite unique compared to other indices. And here she has applied the mean concept, which is a conventional concept from the training data, or considering each sample as a mean. MMD means comparing the two similar fields and what is the membership value. The difference should be tending to 0. If we are comparing with the ISRO goal crop with other crop, the membership value should be close to 1. It should increase. It should be higher inside. This is the bands. If you see for NDVI, if the bands has been selected through CBSI, the bands will come like for this date. These are the bands for this date. These are the bands. So hardly it covers the red band, and here also it does not cover the NIR band always. According to the field situation, you can get the different band combinations through CBSI, but it takes care when you take these two bands in NDVI. This will give you maximum enhancement about that field. Then optimum date, she found 5 dates are optimum, and she has mentioned if you take the 31st December, 10th of January, then 4th of February, like that, the optimum dates can be seen. Also, these are the optimum date: 10th of January, 14th of Feb, 1st of March, 16th of March, and 26th of March, 5 date. And you can see the stages of the crop of ISRO goal. It was budding stage, pollination, ripening, seed maturing, and sun drying of the plant. So these stages of the crop is very important to incorporate of the ISRO crop, to incorporate and map this crop uniquely, and we can get the output. So here, if you see through mean approach, we got very limited fields, right? When it was taken through individual sample as mean, you can see the ISRO goal fields has been increased drastically. And when it was experimented with variance covariance as a Mahalanobis distance, it was giving over classified. So here it is not given best result. And you can see the variance in different concepts while using mean, individual sample, or variance covariance. You can see the variance when it was individual sample approach, it was minimum in the field compared to other methods. So that means it is dealing the variation which is present in the field very nicely. And you can see the mean membership difference within ISRO goal fields, it is quite low. And between ISRO goal and other crop, it is quite high, 0.6. And within ISRO goal, it was 0.04. It is more or less 0, and it is more or less it is increasing towards 1. But here also you can see Fenugreek crop that's called Methi is quite close to ISRO goal. So what we can conclude here, we can map the specific crop while incorporating the different stages of that crop. It can be crop or vegetation, and we can deal the heterogeneity present within class through individual sample approach. And she has also published this paper will be coming up in a month in Remote Sensing Application Society and Environment of elsewhere. The paper called Handling Heterogeneity Through Individual Sample as Mean Approach, a case study of ISRO goal, xylem husk as a medicinal plant. Right. This paper is just submitted and the review it is going on. I will come back to my own slide. So here, I think I talked about this one, cauliflower one. And from my side, I can say thank you. And last year we published this book under Taylor and Francis called Fuzzy Machine Learning Algorithms for Remote Sensing Image Classification. From different portals, it is available as a digital copy as well as hardbound.